You're listening to the Common Descent Podcast.
Hello, David.
Hello, Will.
And hello, listeners. Welcome to episode 199
199
of the Common Descent Podcast.
It's a big number.
We're getting up there. We're right on the cusp of something.
This is the last episode that starts with a 1.
Yeah.
This is it for at least for a while.
Yep. We'll get back around. We'll come back to it. We'll have to have a celebrate. Welcome back, 1.
Welcome back, 1.
We missed you.
The loneliest number.
This episode, we are discussing hibernation.
Don't sleep on this one.
And
if this is the first episode that you've listened to the podcast, this is what it's always like.
Yep, this is all the time. Hibernation is a famous thing that many animals are known to do, that staying dormant typically through the winter. Mm-hmm. But it is so much more than that. There are so many other forms and other uses than just surviving the winter. So we will go through what hibernation is, what it looks like in various animals, and how it is utilized and benefits them. We'll talk a little bit about how we can study this in the past and how we understand its evolution. We'll be talking about this because it's an awesome topic. I had so much fun looking up these notes.
Yeah, this feels like an extension of episode 161, which was sleep.
Yes. This is kind of the other side of the coin, because there's similarities, but it is not sleep.
Yeah, well, when we were planning the sleep episode, I remember for a while we weren't sure if this was going to be sleep and hibernation in one episode, and it turns out, no, those are 2 episode topics.
In fact, you can't do them at the same time.
Oh, that's all right. We're learning already.
The other reason we'll be discussing this is because it was requested a number of times. This was requested by Nora, Tobias, Danielle, Taterboy, Reiko, Milu, Rachel, Sarah, Eva, Jesse, and Jimfire.
Thanks, everybody. This is a good one.
Yeah.
People really want us to talk about hibernation.
Hot topic. Before we jump into the episode and get to our first section, the news, I usually would say brief announcements here.
We got a lot.
It's not brief this time.
It's an exciting time.
But it's good stuff.
Stick through. Because at the end of the announcements, we're going to announce something very exciting.
Yes, absolutely. You're gonna want to be there for it.
Don't skip ahead.
If you have like the 15 second skip, you might be able to time it, but totally it's going to be risky. First announcement is we have a Patreon. Our Patreon funds the podcast top to bottom. It allows us to do all the cool things that we get to do. And when you sign up for our Patreon, you get lots of fun benefits. Extra content from us, extra episodes, live streams, and chats with us. And at certain levels, you can get your name shouted out here on the podcast. And this episode, we'd like to welcome Mark and John Diprototon.
Welcome and thank you for your support.
Absolutely. Thank you so much. If you would like to support us or join in to get your name shouted out or other goodies, check the links in the description to get to our Patreon.
Absolutely. You can also join us on Discord. You can follow us on social media. You can leave us a rate and review on whatever platform you're listening to us. There's many ways to support the podcast.
Indeed. One of those is physical mail. We have a physical mailing address. You can find it in the description and on the site. We got some mail recently. We got some stuff that we ordered for an event coming up that we'll talk about in a moment. But we also got some fan mail. We got a seal postcard from the Swedish Museum of Natural History from Bugs All the Way Down.
Thank you. Very cute, goofy seal.
Absolutely. And we got some goodies from Nancy, some info pamphlets from the Museum of the Earth in New York, and a sand snake, one of those fabric sand snakes.
Yeah, it's very cute.
I love these. They just have it's got like a weighted blanket for your hand feel. They're just nice and satisfying.
Yeah, it's great, and it's all shiny and iridescent. Yes. Fantastic. Thank you, Nancy.
Thank you so much. Speaking of thank yous, we also got some mail from the organizations we donated to with Croc and Snake Month.
Yeah, this year, as we mentioned in the last couple of episodes, we were able to make charitable donations to conservation organizations thanks to the incredible support of our patrons and listeners. And those organizations have reached out to us to thank us. But since you all are the ones who contributed that money that we were then able to donate, I want to read you what these organizations said, at least in part. Turtle Survival Alliance, which we have donated to this year for the first time, we added turtles in, said, "Your commitment to protecting tortoises and freshwater turtles is truly exceptional, and we are honored to count you as a valued member of our turtle champion community. This year, Turtle Survival Alliance celebrates 20 years of conservation action. As we continue to meet the enormous challenge of zero turtle extinctions in the decades ahead, it's supporters like you who keep us in the field. By making a gift to Turtle Survival Alliance, you've supported our initiatives to safeguard turtle species through field research, habitat protection, rescue and reintroductions, breeding and genetics, community outreach, and more." Thank you, everybody, for supporting us in that donation. And while we're at it... that letter came from the president and CEO of Turtle Survival Alliance. We also got an email from the founder of Save the Snakes, who we have supported the last few years, who said, "Thank you so much for your continued support of Save the Snakes. It's so wonderful to have the Common Descent podcast community support our international snake conservation efforts. Save the Snakes is dedicated exclusively to snake conservation and mitigating human-snake conflict. Our mission is to conserve snakes around the world through education, research, and community support." And we mentioned last episode that we also got an email from Marissa Tellez, who joined us a couple years ago on the podcast, who is the founder of Crocodilian Research Coalition. And in her email, she said, "Our Croc Ambassador program is growing, and we are trying to grow our educational program with the new influx of people moving into our area. So your donation has come at a perfect time to further our mission of coexistence between people and crocs." Listeners, thank you so much.
Yeah.
On behalf of us, and on behalf of these organizations, and on behalf of all of the scaly critters that these organizations are going to be able to help, thanks to these donations that we were able to make, thanks to you. It's fantastic.
You all made this happen, so thank you. This year's been incredible. Our next announcement is more of a current update, because we are currently at DragonCon. If you're listening to this on release day.
Yes.
We are in Atlanta at DragonCon, doing panels, walking around, looking at cosplays. If you're here at DragonCon and you've already been to our panels, thanks for coming.
Absolutely.
Great
to meet you.
Haven't been to our panels yet, you can find our schedule. We've posted on our Discord and on our social media and our website. So check that out. You can also look up our names in the app, and you'll be able to find us in our panel. So come see us.
And if you missed us, come see us next year.
Yeah. If you didn't come say hi, if you're at your panels, come say hi at the next one, because we got some goodies.
That's true. We're bringing some good giveaways.
As for upcoming things, we are at the beginning of the month. Since we're in DragonCon, it's right there at that border. Next beginning of the month means new Spotlight episode.
Yes.
Coming up. So keep an eye out for that. We'll be talking to more science educators. And coming up, as you might have guessed, since this is episode 199, is episode 200.
Next episode, we will have a special episode where the topic will be the most requested topic in the history of the Common Descent podcast. Stay tuned. It's going to be big.
Yeah. We won't be releasing what that topic is yet, but we can tell you what another topic is for an upcoming thing, because we are almost at October, which means it is just nearly spooky season.
What's that?
We are getting ready for our Spookulative Evolutions annual series, where we discuss the evolutionary possibilities for monsters, what famous, classic, historical creatures might actually look like if they were real evolved animals.
Yes, so much fun. Every year we have a different theme. We will be releasing, as usual, one episode every Saturday throughout the month of October. There will also be another episode of QD like we did last year.
Yes.
And we'll be doing a spooky live stream.
Yep.
So much cool stuff. Hey, Will, since this episode's coming out and it's September, shall we announce the theme for Spooky 2024?
I think so. Last year, we did dragons.
Yes.
Which are classically very big.
They sure are.
This year, we decided to do the opposite, and we're doing very small, tiny monsters.
Tiny monsters.
The theme is tiny monsters. We will let you guess what that might mean.
So join us in October for a set of big discussions about tiny creatures.
Yes.
It's going to be...
So excited.
It's going to be on. This is such a fun theme. We've been having a whole lot of fun sorting through the possibilities and planning these episodes.
And with that, our announcements can wrap up. Kudos to all of you who stuck through it. Welcome back
shame
to
on
Inning.
those of you who skipped it. You really missed out. You should have been there.
We laughed, we cried, we carried on.
Now that we're 25 minutes into this episode,
Let's dive in, as the podcast saying goes. Our first section is the news. Every episode, we like to cover some recent research in paleo, earth science, evolutionary science news to keep us all up to date and discuss what's happening in science. David, what's the news?
I have a news about fossil walruses.
Nice.
Specifically, a new species of walrus that is strangely familiar.
Ooh.
This is research by Matthew Boisville et al. In the journal Peer J. We will link all of these news articles in the blog post on our website. This one, the article is at Discover Magazine by Paul Smaglick. Odobenidae is the family that includes walruses. We talked about them back in episode 104. Today, that family is extremely small. There are walruses.
Yep.
But in the past, there have been all sorts of other members of this family. One of the most widespread and successful members of this group is the genus Ontocetus, ancient walruses that were spread across the northern hemisphere from the late Miocene through the early Pleistocene, so from about 5 million to about 1.5 million years ago. Ontocetus walruses had a number of notable differences from modern walruses that we know today. For one thing, Ontocetus mainly lived in warmer waters.
Right.
Whereas modern walruses, the genus Odobenus, tend to be cold water species. Modern walruses are also suction feeders. This is a weird, unexpected thing about walruses. Like, the way that they feed is that their mouth and teeth are specially shaped to allow them to create powerful suction.
Yeah, and they just got these, like, pistons of tongues.
Yes. And so they just suck the flesh of clams and oysters and stuff out of the shell.
Which doesn't seem like you should be able to do that without, like, pneumatic pressure from a machine.
And yet, walruses are doing it. Ontocetus, these ancient walruses, are thought to have had a more, normal feeding style, like eating mollusk, eating maybe fish, maybe more generalized, but grabbing stuff with your mouth and eating it the way that, typical animals do. Their teeth are different. Modern walruses have more reduced teeth, so they have fewer teeth overall. Certain teeth are smaller because the teeth are getting out of the way.
Yeah.
To allow for the suction feeding. They also lived at different times. So Ontocetus walruses disappear around the early Pleistocene, well before modern walruses first show up in the fossil record. So they did not actually overlap as far as we know. This study identifies a new species of Ontocetus walrus. They analyzed 2 previously known fossils. These are both lower jaw fossils from 2 different sites. One from the late Pliocene of Belgium and the other from the early Pleistocene of England. Both of these have been previously studied and identified as the species Ontocetus emensi. Here, they do a reanalysis. They confirm that it is Ontocetus, but there are enough unusual features to name it a new species.
Gotcha.
They named it Ontocetus posti. That's fun. A new species is exciting. But what really stands out is that included among the unusual features is changes to the arrangement and shape of the teeth. The jaws have more of a curvature to them. There are a handful of features in the mouth and teeth that are less like other Ontocetus walruses and more like modern walruses.
Ooh.
like in modern walruses, that reduction of teeth and the curvature, they've got like a highly arched palate, things like that. These are adaptations for suction feeding. So, these authors suspect that this new species of Ontocetus might have also been adapted for suction feeding, having evolved a very similar set of characteristics in the mouth, despite being a separate lineage of walruses.
Yeah, these aren't the precursors to today's walruses. This is a different group.
These are fully extinct, different genus that seems to have arrived at a very similar mouth anatomy for a similar feeding style.
Cool. This is neat for a couple reasons, because convergence is always fascinating, especially when it's something weird today. You know, that it's like, it's neat to see that, okay, this isn't, our modern one isn't a one-off weirdo. This has happened in the past. It's extra interesting to me that it's a relative that came to it. Like, so is there something about walrus skulls that might lend itself to this anatomy, or
their diet? The paper mentioned that a lot of these ancient walruses are thought to be mollusk feeders.
Yes.
Even if they're not suction feeding mollusks. Is it that you were eating mollusks and that naturally led into adaptations for suction feeding?
This is a evidently tried and true way to eat this food. So multiple times animal groups came to it. Very neat.
Yeah, they point out that this species, at least these fossils, are from the later part of the time frame of this genus, late Pliocene and early Pleistocene. This is shortly before this genus disappears completely, and it's thought that probably they disappear in large part because there were globally cooling climates during this time, and these were warmer water animals. So the authors point out that this switch over to suction feeding might have been an adaptation to allow this species to exploit food differently or in different conditions or maybe more effectively, that this might have been the environment is changing and this species is evolving these features that are helping it to keep up with these changes.
Yeah.
Though they also point out that becoming highly specialized can also be troublesome when the environment is changing, and that it could be that this species became highly specialized and that actually put them in a corner.
Yeah.
While these environmental changes were going on, and now they're unable to adapt out of that.
Yes, exactly. They became specialized just at the wrong time before these changes these global changes happened. Yeah. Very cool.
Very cool stuff.
Nice. The only segue I could think of is that walrus tusks are somewhat spear-like, and my news is about spear tips and how they might have been used by ancient peoples.
An amazing segue.
Yeah, I thought it was pretty good.
We've been doing this for 199 episodes.
I should have figured it out by now. This is a study looking at Clovis spear tips, which are famous artifacts, and a different way they might have been used than some of the classically portrayed or assumed ways, that they might not have been thrown weapons because they propose that wouldn't have been effective. And so they might have been stable weapons that you use more like a pike. This is research by Scott Bryam, Kent Lightfoot, and June Bueno-Sinceri in PLOS ONE, and the article is by T.B. Puyu in ZME Science. So Clovis spear points are well-known artifacts here in North America. These are found in a number of sites and often date somewhere between 12 to 13,000 years old.
Yeah, these are among the earliest evidences of humans in the Americas.
These are often more robust, stone-bladed tools. They have always been assumed to be spear tips, as the name suggests, connected to the end of a wooden shaft of some sort. They have very distinct fluting and kind of grooved area in the middle where it seems like the stick might have pinched the spearhead on either side. These have often been portrayed as spears, going on a spear handle, a haft, and likely used like a spear. Early humans here in North America were having to deal with all sorts of megafauna, some which were dangers, large predators like saber-toothed cats and big bears and stuff, but also mammoths and other herd animals that there is evidence they were hunting or at least feeding on, and these have often been pointed to as the weapons they would have been using for hunting and defense. How they were used has been point of question just because we don't know, we don't have the direct evidence for how these were used. The typical assumption that they might be thrown at the animal is probably not correct, they are saying, for a couple reasons. One, based on other research, humans probably don't have the shoulder strength to pierce the hide of a big animal.
Interesting. That
throwing these spear tips, and really probably no matter how sharp you got the spear tip, we would not be able to create the force needed to penetrate that thick hide of, especially something like a mammoth.
Yeah, with a throw.
Yes, that we just can't produce the force in throwing.
We're saying this on the tail end of the Olympics.
Right.
So I'm sure there are exceptions.
Yes, exactly. Someone's listening right now with their gold medal going, give me one of those spear tips.
What was it? Was it that Pakistani, the javelin thrower, I think, who set a new record?
Yep.
Maybe that guy.
Yep. There's also the argument that these were probably high-quality tools. Not easy to make. They're not the same as small arrowheads.
Right.
These are robust pieces.
That you want to keep.
That throwing, you might not get that back if you throw it. If you hit it and it stabs in and then that mammoth runs away.
Yes.
You just lost your spear. So they do not think it is reasonable for them to be thrown weapons. What they propose, based off of historical reviews and tests they did.
Cool. Actualistic experiments.
They looked at historical reviews and cave paintings, and they think the more likely way they would be used is as a pike, where you stick the back end into the ground and brace it. And instead of throwing it at the animal, you use the animal's momentum coming toward you, either an attacking predator or a charging mammoth that has been driven in your direction, and their momentum and weight forces them onto the point.
Gotcha.
This has been noted in recorded history, used against other animals, but also in war situations, war horses and stuff. Pikes are a common tool throughout human history in various cultures. So it would make sense that our ancient people here in North America could have come to the same conclusion. They also did tests to see how a pike made with a Clovis point type head would respond when force is put upon it in that way, and found that it does seem to be effective. But they found something interesting. Now, I'm going to try to explain this as best I can. The paper was fairly technical, and the article doesn't go into as much detail, but based off the pictures and from what I could get, it seems that the spears were likely a fairly complex structure with a wooden haft and then a bony rod used as the pinching other side for the spearhead. That you would tie the rods together and then they would pinch the spearhead between them. So, use whatever sort of fiber they use to tie those together, and that would hold the spearhead. There have evidently been found what they called osseous rods, which took me a second to realize, bone rods.
Yes.
Bone sticks had been found in association with some Clovis points. And the shape of them, it turns out that when you tie them together and the spearhead stabs in, if the spearhead hits a bone or something or gets dislodged, that the fluted shape of the bottom of the spearhead would force the spear handle and the bony rod apart into the wound.
Yeah.
And as they compared, acting like a hollow point bullet and causing internal damage because the spear tip gets through the hide and then the two tips of the two rods get forced apart into the wound. So it's based off of their research and their tests, it seems like not only were these spear tips probably not spears but pikes, but they were also probably high-tech killing weapons for the time, both for defense and potentially hunting, and that they might have been fairly sophisticated mechanisms, once again supporting that you probably don't want to throw this.
Right. You
want to hold on to this and make sure you use it and don't lose it the first time you throw it.
That's very cool because it isn't, I think, what comes to mind first. I think that there is a tendency to look at ancient tools and assume that they were being used in the most simplistic and obvious ways possible. And I'm sure that there were a bunch. That was this is a cutting edge. We used it for cutting.
Well, I'm sure you could just use a sharp stick and use that to throw and harry the animal.
Absolutely. Like, yeah, that makes sense, and those are reasonable ways to do it. But it's very fun to find potential evidence of these early technologies being a little more complex, being a little more high-tech, as we might call it, than we would first expect.
Yeah.
That, yeah, it's very... If you handed me a spear-shaped thing and told me I had to fight a mammoth, I would throw it.
Yeah.
Absolutely. I would throw it, and it wouldn't work, and then I would give up.
Yes.
And then I would leave.
Why would I want to get close to that thing?
Yeah, if your suggestion is that I hold it into the ground...
Be real stable now.
While it char like the extras in that one scene in Lord of the Rings when the whole herd of horses is charging at them.
Yep.
You're like, that's a lot. I don't know if they were extras. They were the orcs and stuff.
Yep.
But it's very fun. It makes me wonder if there is variety among the Clovis points, and I wonder what would it look like. Would there be notable differences between a stick that was made to be thrown at prey and one that was a stabber and one that was a pike that you stuck into the ground? Would we be able to see those differences?
Yes, because we know that historically many cultures have used throwing spears.
Absolutely.
So there's definitely a benefit to them. I don't know, and this is just me off the top of my head, I feel like most of the ones I'm familiar with are war weapons, not hunting weapons. That they're battle and not used for hunting. And it's a point that gets made for like throwing knives. They're fun in video games, but now you're out of weapons.
Yeah, now you don't have your knife.
Yeah, it is much better to hold on to that knife and not throw it away.
Because there aren't extra knives lying around in bundles of
floating
5 all around,
over crates.
Yeah, all around the battlefield.
So yeah, interesting look at a potential rethinking of some of our early technology.
Very cool. Well, speaking about news about stuff from the past, I have another bit of news. This one's about grapes.
Ooh.
Specifically the fossil record of grapes and new insights into grape evolution. This is research by Fabiani Herrera et al. In Nature Plants, and we will link to an article in Sci News by Enrico De Lazzaro. Grapes belong to a group of plants called Vitaceae. This includes grapevines in their many forms and shapes. It includes things like Virginia creeper, lots of vines, climbing plants. The oldest known grape fossils come from India at around 66 million years ago. So right after the end Cretaceous mass extinction.
Excellent year.
I don't know about that. That was a real rough year. It is thought that this makes sense because this is probably a group of plants that radiated and diversified after the extinction event. That you had a somewhat clearing of the slate of a lot of ecological space, and new plants and animals were diversifying to fill those new roles. Specifically, some researchers have suggested that with the loss of so many large animals, not just dinosaurs, but including them, you might have ended up with denser forests because there aren't as many large animals disturbing them, and denser forests might have been a good situation for climbing plants to evolve and diversify. So it may be that climbing plants, grapevines in this case, did well in that new ecological structure.
That makes a lot of sense.
But we just don't have a whole super extensive fossil record of grapes, so it's hard to know details of their evolution over time. This study describes fossilized grape seeds, so you can get the seeds of grapes. We have grape seeds from the Gray Fossil Site that have been ID'd as new species.
I forgot that.
This study describes fossil grape seeds from 4 different fossil sites, ranging across the Cenozoic era.
Okay.
So the 4 sites are within the Bogota Formation in Colombia, which is about 60 million years old, the Tenosi Formation in Panama, around 41 million years old, the Mancora Formation in Peru, which is about 28 million years old, and the Cucaracha Formation in Panama, which is about 19 million years old.
That is a good spread.
So this spread across time. That last one they mentioned in one of the articles, that this geologic formation is exposed in one of the areas where the Panama Canal was cut to be built. So that's pretty cool.
Neat.
These grape seeds that they describe include 9 new species.
Wow.
So across all these sites, they name 9 new species. I don't have the names for all of them, but there is one that gets consistently focused on in the paper and in the articles. Lithova sesmanii from the Columbia fossil site, 60 million years old, making it not only a new species, but the oldest known grape in the Western Hemisphere.
Cool.
So we've got the Indian grapes at 66 million. This is here in South America at 60 million. So a very, very early here in the Western Hemisphere.
Very nice.
The researchers also performed phylogenetic analyses to place what groups do these new species belong to get a sense of what do their relationships tell us about what has happened with grapes and their relatives over time. For one thing, the fact that there is such an ancient species within this group here in South America supports the hypothesis for a South American origin for the group of plants that includes our modern common grapevines. So this might be where that portion of the lineage got started. It also shows how different groups of grapes were spreading across the Western Hemisphere, and, very notably, highlights different changes over time. So they point out that some of the species they've found in this sort of South and Central American region belong to groups that don't live in those regions anymore today. Some of the species are also most closely related to groups that today are in the Eastern Hemisphere, not in the Western Hemisphere. And this is interesting because it shows that different groups have been moving around and changing their distribution over time, which means it hasn't just been as simple over time as grapes got started and radiated and became more diverse and went to new places and got more successful, that there have been not only dispersals and radiations, but extinctions and disappearances.
Yeah.
That some events caused groups to move into new areas and become more diverse, but other periods of time you lost groups in certain regions of the world or certain types of environments and such. So there has been this complex combination of these effects.
There's always something very fun about when we find fossils of a group in an area where they're known today and are like, yeah, no, this group's been here for this many million years. Not these ones, though.
Yes, different one.
Different ones. The ones that used to be here are now over there. That lineage survived over there, not here. These are different. It's that lovely reminder of like, yeah, I know. Throughout the millions of years that a lineage can be around, they can move back and forth across various continents and hemispheres. You have the wonderful things of them originating in a place, going away there, moving somewhere else, and then coming back there later. And I like when that happens because it's a nice reminder to, like we were saying with the tools, like pump the brakes. The obvious answer might be too obvious.
Yes. Well, we talked about it reminds me of a part of what we talked about in episode 169 about sea snakes.
Yes.
I was like, yes, there were sea snakes in the Cretaceous, and there were sea snakes in the Paleogene, and there are sea snakes today. 3 different groups of sea snakes.
Yep.
Not related to each other. 3 different times that snakes did that same thing.
That's like just saying those 3 times is a true statement.
Yes.
What it suggests is wrong.
Yes.
I like when that, I don't know, it's just very satisfying and funny to me and a good reminder.
Yeah.
Very cool. Neat. These might pop like grapes if you were able to.
That doesn't make me excited about it.
You know?
This one's about eyeballs.
Tardigrades.
It's not worse, but it's also bad.
Tardigrades, water bears. This is a study on 2 fossil water bears from some amber that is a new species and is maybe giving us better clarification and resolution on the evolution of this group.
Ooh.
This is research by Mark Mapallo, Jonah Wolf, and Javier Ortega Hernandez in Communications Biology, and the article is by Andrew Paul in Popular Science. Tardigrades, water bears, you might have heard of them because they've become very famous in recent years. These are very small organisms, a phylum of life unto themselves, which is always a thing that I forget.
Yes.
These are very tiny invertebrates. They are very successful today. There's over 1,000 species known, widely known across many different habitats, often in water. They live in water droplets and also water aquatic ecosystems, famous for their extreme survival capabilities. They can do what's called cryptobiosis, where they expel the water from their body, shrivel up, tuck their arms in, and can survive freezing and dry and harsh and radioactive and space conditions. All the crazy stuff. These are also some of the oldest, like one of the oldest known lineages on Earth. Like, they've been around for a very long time. Molecular clocks, judging based on the mutation rate and the diversity we have today, suggests that they likely split from panarthropods before the Cambrian. So a ways back before most of our fossils go back to.
Some 600 million years or so.
Today's tardigrade species likely showed up somewhere between 155 and 66 million years ago during the Cretaceous. But they've been around for a long time. But exactly where they came about and exactly what that evolution looks like is not clear, because these are very tiny, soft-bodied organisms. They do not fossilize well. The paper noted that at the time that they were writing it, only 2 fossil tardigrades are resolved with taxonomic positions.
Wow.
That there's only 2. There might be other suggested ones, but there's only 2 that have actual positions that are agreed upon.
Yes, like we know what kind of tardigrade this is.
So they are very rare. These are from the late Cretaceous and Miocene. I'm not going to say the names because they're very long and weird. This study was looking at a amber specimen with 2 tardigrades that is not new, but had not been studied because of the condition of the amber. This is Canadian Cretaceous-aged amber, somewhere between 72 and 83 million years old. It was housed at Harvard's museum and has been there for decades. They didn't say the specific year, but it's been there for a while. They couldn't get a good look at it due to the opaque color of the amber, the size of the fossils, and the lack of technology that could handle that back then. Now we have the technology. They used confocal fluorescence microscopy, which is very fancy digital microscope techniques that allow them to get layered images that they then can put together into a 3D image of these organisms. This allowed them to get a good look at some critical anatomical features and identify what these tardigrades are and use them as a new data point in that molecular clock analysis and get a better resolution on what was going on with the overall group. The 2 tardigrades are separate species. One, an already known species, Bjorn legi, but they did get a better look, and it revealed that it has Hypsibius-type claws. Oh. Which, if you're a tardigrade fan, I'm sure that's obvious to you what that means.
That's so... Well, the best kind of claws.
Hypsibius, it's whatever I said earlier. It's got...
Hibiscus, is it?
Hibiscus claw. No, it has particular kinds of claws that allow them to better ID the anatomy of this extinct group.
Okay,
cool. So they got a better look than we had of this. This is a reanalysis, basically, of this species with this new analysis. The other is a newly described species, Aerobius dactylus, based on its unique combination of claw features, which gives me the implication that evidently claws might be very indicative of tardigrade groups, which is interesting because it's one of their most famous features, why we call them water bears. Yeah. They've got little itty-bitty clawed paws. Phylogenetic analysis of these 2 indicate that they are in the same superfamily, and adding this data to the molecular clock estimates suggests that an early Paleozoic diversification of tardigrades is more accurate. And comparisons between these fossil specimens and modern tardigrades suggest independent terrestrialization of this group, of this supergroup and another supergroup of tardigrades, suggesting that they both made it into drier environments separately, probably around the in-Carboniferous for one group and the lower Jurassic for another, which also suggests 2 separate origins for cryptobiosis.
Oh, interesting.
That likely there were 2 different lineages that came into drier habitats where they deal with situations where they need to dry out, and both likely evolved that separately.
Interesting. So this is a common thing that we end up doing with the fossil record, is we have all this DNA data, that gives us these estimated dates, but then when we find fossils, we can go, cool, these represent these lineages, and now we have a time period for them. Let's plug that into our analysis, and that calibrates the clock. So this sounds like it's suggesting that adding these into that analysis suggests the original diversification for tardigrades, perhaps not just before the Cambrian, but perhaps a little after the start of the Cambrian, early Paleozoic, but also that multiple lineages moved onto land independently and adapted features for surviving on land independently.
Absolutely. Which is very cool because that's just one of the most famous things about the group. So the idea that it might have evolved twice is very intriguing.
Yeah.
And is an excellent segue into our main topic. This extreme form of dormancy is a great jumping off point to leave the news and move into our main discussion, hibernation. What is it? How do you do it? And what are the benefits? Stay tuned after the music to find out. Hibernation as a term is one that many of us are familiar with because it's one that we even use. Like, it gets used day to day. Long rest periods is the general concept of hibernation. Long periods of low activity, and it's often used in our like colloquial terms of long sleeps and whatnot.
Yeah, well, like my computer has a hibernate
mode. Yes, exactly. Hibernation is a feature used by many organisms and is a key tool for survival. Typically, it referred to, traditionally, deep hibernation in rodents. That was actually one of the main things that, like, old researchers, if they referred to hibernation, they're referring to rodent. And ground squirrels get referenced constantly. They are evidently big-time hibernators. It is a very common thing among their group.
Yeah, that's why they're collecting all those nuts and stuff.
Yep. And so they are very well-known hibernators. Later on, it got applied to other animals. It actually took a while for bears to be recognized as hibernators, even though they're so famous for it.
Interesting. Yeah, today. That's like that's the animal that comes to my mind first.
If you see a cartoon bear, it's like 50-50, it might be hibernating. Their hibernation is actually a little bit unique, so it took a while for it to fit, to be applied to the definition, because it doesn't fit most other animals' way of doing it. Now it applies to basically any form of suppressed metabolic state, typically in sync with lowered body temperature, lowered activity, a period where your metabolism, your body temperature, your activity are all lowered and suppressed to save energy.
Like the hibernate mode on your computer.
Exactly. This, as a definition, is now referred to, like that strict state is torpor.
Okay.
Low metabolism, a physiological state that is temporary, low metabolism. There are different forms of it, different causes for it, but that's what torpor is. Very often you'll see kind of torpor and hibernation as two different things, when in actuality there's torpor and long torpor.
Right.
Hibernation is just a long form of torpor.
Okay.
We'll get into more details, but both of these are forms of dormancy. And there's some kind of like categories that dormancy will get put into. The two that I found most often were predictive dormancy. I saw one time it basically was the same definition of obligate hibernation. These are situations where they enter a dormant state before the onset of whatever the situation they're going dormant for is.
Right, so preemptive, right? I enter hibernation before winter sets in and I can't get any food
Not
anymore.
because winter has already come.
Yes, winter is coming.
Yes.
And so let's enter hibernation before that happens.
These are often forms of hibernation and torpor that are reacting to environmental cues, changes in temperature or daylight or barometric pressure.
Premeditated torpor.
Yes, exactly. Consequential dormancy or facultative hibernation is entering a dormant state after the situation.
Yeah, things are really bad, I need to go to sleep.
I should probably take it easy.
Well, this is what we think, like we were talking about with tardigrades.
Uh-huh.
Like, if you put a tardigrade in space, it enters this dormant state to allow it to survive.
Yes,
and it will come back out when there's water again.
Things are bad, so I need to hunker down.
Yes.
These that might seem like the less stable, but it can have more advantages because you have more time. Mm-hmm. You can go right up until the last moment and then go dormant, and you might get more time to get more resources or take advantage of things up until the last moment. These are extremely variable. Evidently, there's 2 prairie dogs, both related to each other. The white-tailed prairie dog is obligate. The black-tailed prairie dog is facultative. So it is not a thing of strongly this group is this way.
Yeah.
You can have a lot of variation. Of course, like most nature things, there can be a gradient and slight differences that fall between those two. The 2 main groupings that you'll see, though, and these do seem to be fairly distinct. Still, there's a gradient, but these are often the 2 main groups that get used is daily torpor and hibernation, or multi-day torpor. Hibernation's the famous one. You go to sleep for weeks or months, and usually to survive winter is the go-to example.
Like we go to sleep in the fall, wake up in the spring.
Yep, when things are bad, we just hibernate. And then we rouse when things are better, and now food is growing again, and we can survive. Daily torpor is used for typically less than the length of a day, and is sandwiched by active periods, and is often unconnected to seasonal effects. It will often increase during harsh times like winter, but they'll use it year-round, and it's used for, I'm feeding this time of the day, I'm taking it easy this time of the day, either because it's when the predators are out, or it's when things are tough, whatever it is, for every reason, this is not the time to go foraging, so I just go into torpor, turn the system off a little bit, and then I turn back on when it's time to go eat again. And they just use it during the day. Much more flexible, much more variable, and not nearly as cue dependent. Hibernation's often triggered by the environment shifting. Daily torpor could happen just whenever it is best for that animal to not be using up a lot of energy. There are a bunch of animals that use these techniques, but basically all of them, at least the ones that truly are said to use torpor in hibernation, are what are called heterothermic. So we've gone over this concept of endotherms and ectotherms.
Yes, we talked about this in episode 179.
Ectotherms do not make their own heat. They have to use the heat from the environment or find cool spots in the environment to warm or cool themselves down. Endotherms can metabolize and create their own heat, and also often have ways to cool off physically as well. So those are often presented as the 2 options. We've talked about the fact that it is not a dichotomy.
Yes.
But not all endotherms are permanently homeothermic, meaning that they just maintain that one temperature.
Yeah, this is the thing that we are very good at as mammals generally. Not only generating our own internal heat, but staying at a very stable temperature.
There are endotherms, warm-blooded animals, that can basically term off their homeothermic stability and go to heterothermic and function much more like a reptile, poikilothermic, where their body temperature will fluctuate much more with the environment. Not quite as 1-to-1 maybe. There might be it's a gradient. They might just be closer to that. But heterotherms are a type of endotherm. There's lots of therms, but heterotherm means they can vary their body temperature, but they also can control it when their homeostasis is turned on, when their metabolism is turned on.
Right. So for us, we are homeothermic endotherms, which means we generate our own heat, but we do not fluctuate very much. If your body temperature fluctuates more than a few degrees, that's a problem.
Usually something serious is happening.
Something is wrong, and that can be damaging or fatal. These are animals who maintain a high body temperature, but under certain conditions can actually drop their body temperature significantly lower than our bodies could handle.
Yeah,
then go back up when the time is right.
It's kind of like the difference between if you lived in a dorm in college where you didn't have control of the air conditioning versus having control of your own thermostat.
Yes.
Heterothermic animals, as a rule, for the most part, can use torpor. This is what allows them to use torpor. Now they can lower their body temperature and their metabolism and go into torpor. Us, Homeotherms can't do that.
Nope.
If we lower our metabolism that much, we just don't wake up.
We don't come back.
we just turn off all the way. There are forms of torpor and things called hibernation in ectotherms, your cold-blooded animals. We'll talk about that a little bit more later, but it is not the same because they can't lower their metabolism. Their metabolism fluctuates with the environment as the temperature around them fluctuates. So their body temperature and metabolism aren't able to be controlled the same way, but they can still go into similar states.
Yes, and they can still activate or deactivate different parts of their bodily functions.
Yeah, so there are parallels, but mostly it's usually talking about quote-unquote warm-blooded animals that have the ability to allow their body temperature to adjust. And these are the ones that use torpor in hibernation. The two main versions of hibernation and daily torpor do seem to have very similar overlaps. They're both ways to respond to situations that are unideal. Winter is what we typically consider hibernation used for, but the reason you use it during winter is because that is a hard time to be alive.
Yeah, it's much colder. There's not as much food.
There's not as much sunlight. There's maybe your environment is gone because the leaves have fallen. Like your environment might not be conducive to you. You may no longer blend in with the environment. If it's snow, lots of reasons it might be harder to be whatever you are during winter. So going into this low energy state is a way to handle those stressful times. Hibernation, long-term torpor, is known in tons of groups. Lots of mammals, monotremes, marsupials, and placentals all show forms of hibernation. There is but one group of birds that has been noted.
I was wondering.
Yeah, the common porwheel, which is in the nightjar group, has been noted. And I saw some other members in this group that'll get mentioned that also have been noted. There are birds that show torpor, but evidently they're the only ones that really count for hibernation.
Interesting.
This long form. There are some things that are often very commonly shared among hibernators. Usually they fatten up or prepare before hibernation. So it's not just I should take it easy. It's, need to start getting ready.
Right. For a period of weeks or months, we're eating more, we're stashing food, we're finding the place that we're going to hibernate. Like I said before, it's premeditated.
Exactly.
You prepare for it ahead of time.
Yeah. Bears eat a ton more and build up fat in a specific way. Their physiology changes to build up fat for hibernation. Lots of rodents make food caches. The hiding of acorns and things like that. The hyrax that gets the toxic plants so that they stay in its nest. Then they enter their long period torpor. They usually do not stay in torpor the whole time. We talked about this in the sleep episode. There are periods of arousal throughout the torpor where they warm back up and are active. And truly, we don't know why this happens. The leading idea is that it's to sleep. That while they're in their low metabolic state, they build up sleep debt, which we talked about in the sleep episode, and have to warm back up, not wake up, warm back up, to then go to sleep for a little bit.
Yes.
Then wake up and cool back down to go back into torpor.
And this is an interesting and important dichotomy. We have, a couple times already in this episode discussion, casually referred to hibernation and torpor as going to sleep.
Yep.
But it is not.
It is not the same.
It is a different thing than sleep.
Like, your metabolism does dip when you go to sleep, and your activity does dip, and you do cool off a bit, but your body's still pretty much functioning. Your metabolism is not turned off. You can still digest everything. Like, you are still functionally in your normal temp. Like, if you take someone's temperature when they're asleep, it's not going to be 80 degrees Fahrenheit.
Right.
It's still going to be that 97.6. I always forget if it's
98.6
98.6
or wherever your thing falls.
It's still going to be their resting temperature. So asleep and torpor are distinctly different to the point that you might have to stop one to do the other, which seems weird.
Yes.
But
you have to wake up for a bit so that you can sleep.
Yeah. There are other reasons that they might arouse. If you're a food cache animal, you need to wake up to eat because you don't have a bunch of fat stored. Like a bear.
A bear can have hundreds of pounds worth of energy to burn through.
So they can just metabolize that fat while they're in torpor. Rodents are going to have to wake up to eat a bit Typically, they don't have to wake up to drink because most hibernating animals recycle their urea, so they don't have to pee.
Efficient.
And they don't have to, therefore, replace their water loss, and they're getting water from the fat they metabolize.
So they're like Iron Man.
There also might be a reason that to warm up to get the immune system running again.
Oh, interesting.
Yeah. Because your immune system dips with lower temperatures.
Yeah, if you're slowing down all the body functions, that's all the body functions. And some of those are important.
So it might be kind of like a systems check. Warm up, run a virus scan.
Yes.
Literally. And then you cool back down, go back into torpor. These periods are also very interesting because they are the most costly aspect of most of the energy used during hibernation are used warming up from hibernation and cooling back down. So they're very costly. If they could not do that, then hibernation would be
save way more energy.
Way more efficient, but these are necessary for most hibernators. You do find forms of long-term hibernation that are more flexible, especially animals living in more mild climates that don't have harsh winters but have cold times, but they might be interspersed with warm days. So you will see some that wake up in the middle of hibernation, go out and eat a little bit, and then go back in hibernation when it gets cold. So there are some that kind of are doing a mix of that premeditative and reactionary. Others will terminate or stop it at different times depending on what the weather's doing that year. So it's not always strict for all groups. And then the most reactionary is daily torpor. As I said, this is not specific to times of year, but can be specific to different times of day. Nocturnal species often use torpor at the end of the night, beginning of the day, as they're starting to wind down to their inactive part of the day.
Yeah.
And diurnal animals will start using it toward the end of the day as they're winding down toward night. So they'll use it during the time they're not active. So there are plenty of animals that are using torpor in the middle of the day, when it's not ideal. The sun's directly above or something causes it not to be good. Lots of desert species do this.
I was going to say, because that's the worst time in a desert is the middle of the day.
Find some shade, hunker down, and just turn off for a bit until the sun goes away a bit more. They do not tend to do pre-fattening beforehand. And in fact, they tend to only go into torpor for situations like that if they are lean. If they're like, ooh, I'm not doing too well.
Right. I'm really running on fumes.
Let's take it easy for a moment and wait till things get a little bit better. Hibernators often won't hibernate if they're lean.
Right.
Because they need that fat storage.
Yeah, because if you go into hibernation for a month and you were already not doing well, you might not be coming out of hibernation.
You don't have enough fuel to make it through. So they're often used in kind of opposite conditions of the animal.
Yeah.
Where one is oh no, I need to pull my trump card out of torpor.
Yes.
The other is, no, I've been planning for this. If I didn't do it right up until now, I can't do it. If I did not plan ahead, I'm not going to hibernate this year. I'm going to have to just find food this winter. There are lots of other reasons and situations that torpor can get used than just winter and rough times a day. Already mentioned a couple times is extreme heat.
Yep.
Extreme heat of the day is a really great time to use it, not only because you avoid that harsh time, but lots of animals that use torpor can also allow their body temperature to rise. They allow their body temperature to be more flexible and meet the environment instead of trying to keep themselves cool. They just go with the flow.
Yeah.
Their body temperature rises. They're no longer using as much energy to try to cool themselves and just are allowed to be hot for a bit. But
without affecting the body processes like it normally would.
Absolutely. Some can do it extremely. Camels were noted for being able to do this, and the fact that they only do it if water's not available. If water's available, they use water, and they use evaporative cooling to cool themselves off. If water's not available, they start allowing their body temperature to adjust, and their body temperature can rise a bit. The most extremes were small desert bats, which evidently can reach some of the highest body temperatures of any mammal. Camels were noted to increase up to 41 degrees Celsius or 105 degrees Fahrenheit body temperature. Bats were found reaching 45.8 degrees Celsius or 114 degrees Fahrenheit.
I think when I did 179, when I took the notes for thermoregulation, I could be misremembering this, but I think 45 degrees Celsius was one of the often given numbers for if you get hotter than this, biology stops working.
Yes. Yep.
Like, this is about the cap. Your enzymes and proteins start falling apart if you go any higher than this.
So there are many animals that have adaptations to their version of torpor, and one of the ways it affects is they can allow their body temperature to rise without breaking things down.
Yeah.
But they still need to kind of shut down because, you can't function normally at those temperatures. So you still need to go into torpor, but you're not cooling down, you're heating up.
Interesting.
This was often called thermoconforming.
Yeah.
That you're conforming to the environment and riding out that heat wave so that you can then go back to a functional temperature. In line with this, saving water is a great use of torpor. Not only for things like hibernation, where you're recycling your pee in a weird ergonomic way, but also that if your metabolism is lower and you're not having to maintain your heat, you're not having to evaporate sweat or pant or whatever it is that you do to evaporate water to cool yourself off. So you save that water.
Yep.
So if your body's not a huge difference from the outside temperature, then you don't need to adjust it. So you get to save all that water. This has been noted in a ton of animals. Some it's been known to reduce evaporative water loss from up to 20 to 40% from an active animal. So huge water savings. This means that torpor can also be very effective in specific scenarios like droughts.
Yeah.
That if you can just go, you know what, guys? I'm going to check in when the rains come back.
Yep.
I'm going to go into my burrow, and I'm just going to take some me time and go into hibernation. Then you can just wait out droughts.
Yep.
And potentially, or at least minimize the time you have to spend being active during a drought. Because droughts might last for years.
Yeah.
But you can... Basically, you're playing the game less.
Yes.
You're logging on less.
Yeah.
So you can weather these harsh times. This also goes for things like storms. Animals have been noted to use torpor during storms. Things that are very equivalent to winter, like blizzards.
Yep.
Getting snowed in can be a good time to use torpor. That was noted in hoary bats. Pregnant hoary bats just went into torpor during a blizzard, but sugar gliders were noted to use it during a cyclone.
That was what I was going to ask.
Absolutely.
Like during hurricanes or stuff like that.
Yeah. If you can just find a place to hunker down and just wait the storm out.
Yeah.
And you don't have to have a bunch of food saved aside like we do. You just don't eat during the storm.
Yep.
Then that's great. You don't have to go foraging in the middle of a hurricane.
Yes. Well, and that's an event that can go on for, the impacts can be a few days.
Yes, absolutely.
There could be the storm, and then there could be after effects of it, or, the flooding has to die down or whatever. That's a nice way to just, we're just going to skip that.
So if you only have to be active half that time, that's still a huge advantage to the homeothermic animals that have to keep feeding the entire time or go hungry. This also applies to things like fires.
Yep.
Now, there is a little bit of a hunkering down in the middle of a fire.
Yeah, well, very much like that hurricane. The storm surge might be a problem for you.
Where you hunker down is very important in these scenarios.
Key. Location.
But if you do have a safe spot like a burrow, and you can just wait out a wildfire, that's a big deal. It also might help after the fire, when the environment has been destroyed.
Yes, when there's not as a lot of food or shelter around.
And when there's a lack of shelter, that often increases predation risk, which is another thing that is often associated with torpor. If you just go turn off when your predators are active, and you only forage when they aren't active, then you're not having to go hungry while they hunt for you. You just sit and slowly digest the food you found earlier. You save that energy, and then you activate again when hopefully your predators. So it might decrease your interaction with predators because you have to forage less.
Yes.
You don't have to eat as often because you're not using as much energy. So it just makes you a more efficient interactor with your environment. Similar to that in the foraging less and saving energy, migration.
Yep.
Lots of animals use torpor during migration. Is when we take a break, we're not just going to sit and catch our breath. We're going to sit and turn off.
Yes. A recharge.
We're going to fully just save energy during this rest period and let our muscles, recalibrate, but also just use as little energy as possible.
And save that up because then we have to continue migrating.
Yeah, we've still got 2 states to cross.
Yeah, a massive expenditure of energy.
Hummingbirds have famously been noted during their migrations to heavily use torpor. They also use daily torpor if they can't find enough nectar.
Sure. Well, a hummingbird has a very high requirement. That is a high needs bird.
So they are very hot cold. They're buzz, 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 buzz. If they can't find enough food, they turn off.
Yes.
And because that's the only way they're going to survive.
Yes. Well, it's like when you don't have your phone charger.
Yeah.
But you're traveling around. It's like, I just turn it off when I'm not using it.
I'm at 5%. I'm an hour from home. We're just going to turn this off and hopefully
yes,
I can just get it to a charger once I get home. This long distance use might also have been useful for colonization. We've talked about island hopping with animals.
Mm-hmm.
If an animal gets caught on some natural raft, a piece of debris, cast out to sea, and is going to make it to an island, you have to make it across the ocean first, where there's no food, no fresh water, intense sunlight. If you can just torpor through that trip, that might increase the chances for heterotherms to be better at colonization this way.
Yeah, at making it to new regions, new habitats.
This is also useful because one of the other things that often goes with torpor is it can affect reproduction cycles. There are many animals that will use torpor to delay births.
Yeah, they can pause
Yes.
that gestation cycle.
Because as their metabolism goes down, the rate at which they are nurturing the young growing inside them goes down. So the rate it develops slows down, which sounds like a bad thing you'd want to do to an infant.
Well, and in like humans or other homeotherms like us, that would be bad because now that's bad not only for the parent body, but the developing embryo.
But in this case, you all just slow down for a little bit.
You're hibernating for 2.
Yep.
Or 7, or however, whatever your litter size is
your
going to
brood. And then when things are better, you can warm back up from torpor. Pregnancy takes its normal course, and now the young will be born in a better situation.
Yeah, instead of being born on that raft across the ocean or during that drought or whatever.
Which is another way it would make them better colonizers, because they can come in with reinforcements ready to go.
Yes. Yeah, they're already the ship, Trojan horse that has moved into this new island area.
And so they can give birth upon colonization and start the population much more effectively.
That's an aspect of it that is interesting looking back throughout evolutionary history for how we understand groups of animals get to different places.
Another aspect of reproduction that evidently torpor comes into play is sperm storage. So many female animals can receive sperm from their mate and then store it, hold on to it, and not fertilize the eggs with it until a certain time. This could be a seasonal thing that they mate before winter and then fertilize after winter or fertilize when things are better. But evidently, torpor is a big factor in lengthening the available time that sperm can be stored.
Interesting.
We see the longest sperm storage in animals that use torpor. Once again, bats show the longest time for mammals, up to 225 days.
Wow.
Almost a year.
You just put that stuff on the shelf.
Yep.
You stick it in the freezer and you just wait it out.
Good for the Armageddon. This, once again, can allow for timing of pregnancies and reproduction. It also can allow things for like separation of male-female reproduction. Like the males can be active, mate, and the females can do their step when it's convenient.
Yes.
So it can separate. You don't have to all be active at the same time.
Well, and it also means like the best time of the year for mating is going to be different than the best time of the year for giving birth, and those might be farther apart than normal gestation would be.
Absolutely.
It's like this way, if the best time for mating is this time of the year, then if we just let that pregnancy go as normal, we're giving birth in the middle of the winter.
Exactly.
So hold on to that, give birth in the spring.
There are some animals, though, that purposely give birth during the winter. Bears are noted famously. Yeah. Female bears give birth to their cubs during hibernation. And the reason for that evidently is that the baby bears can't get nutrition from the fat metabolized by the female. So they need to be born so that they can drink the milk that will be created through metabolizing that fat. So they have to get born during winter so they can nurse during the hibernation. They can't hibernate, but they will nurse while the female hibernates because of the way the metabolism works.
Seems like one of those classic examples of evolution not quite managing the perfectly efficient version.
Well, it's like the pictures of the various plug adapters to get your computer to charge overseas. There are other animals that will use torpor during lactation to slow down and adjust the rate at which they're producing milk and the amount of energy and nutrition going to that, or to fatten up and save fat and save energy in anticipation for lactation.
To then convert into milk
Yes.
later on.
So they'll use torpor to be more efficient beforehand and build up energy by saving it during torpor times, and then be able to lactate and feed their young.
Also, from what I've heard from people that I know who have experienced giving birth and breastfeeding, being inactive during those events might also be more pleasant.
Right? Absolutely. Like, simplifies it a
Just
lot.
wake me up when it's all over.
One of the most extreme forms of reproductive torpor I found are European edible dormice, or fat dormouse, which were named by the Greeks because they ate them.
Okay, edible dormice is like an Easter candy.
Yep. This is what you get at the club.
That's right.
An edible dormouse. These are evidently
That's the
large.
form it takes.
Yes.
It's like a gummy. You have a gummy, you can have a brownie, you can have a mouse.
It sounds like something from D&D.
Yes, it absolutely does. Once a day, this bag produces 1d4 dormice that provide 1 HP and a day's worth of rations.
It's like the carnivorous druid's Goodberry.
Yes.
These are...
The Goodberry doesn't have all the proteins
Nope,
that you need
nope.
to develop your brain and everything.
Listen, the Goodberries are out of season right now. Have an edible dormouse. Anywho, these dormice can hibernate up to 11 months during non-reproductive years. So they don't reproduce every year.
Huh.
And during years where it's not ideal for reproduction, I didn't go into detail to find out what makes it more favorable and what their pattern is.
Sure.
But basically, they'll skip years.
Just a whole year,
If they're not going to
essentially.
reproduce, they just hibernate
Wow.
all year and then can reproduce the next year. And so it's just, there are some times where it is extreme how it plays into their life. And this is not for seasonal purposes. This is
Right.
for reproductive purposes.
Yeah.
There also seems to be health benefits that go along with torpor, some which are very tied to it, obviously, like parasites. A lot of parasites seem to not do well while their host is hibernating.
Yeah.
Because the temperature's changed, their metabolism's changed, other aspects of their physiology might have shifted, and it just doesn't make it ideal. It's been noted in marmots, another kind of ground squirrel, that a bunch of their parasites leave while they hibernate and have to go find intermediate hosts or something.
Well, fine.
Yeah. And then
Look at this hotel.
Oh, yeah.
A 2-star review. I'm fine somewhere else.
would not stay again. And then things warm up again and they go, okay, well, I'll give it
All
another.
right, well, sure.
And you see the parasite numbers rise again. But evidently it could be a resistance to parasites.
Yeah.
There's also a lot of correlation with longer lifespans.
Oh, yeah.
A lot of hibernating and torpor-using species live just longer than their non-hibernating, non-torpor relatives.
Interesting. You're wearing down more slowly.
Yeah, it might. I saw one just noted like it's a slow-paced lifestyle, so it just you might be wearing down more slowly. You just might not be putting yourself in as much danger. Some of it might be direct stuff of like if you're avoiding predators.
Yes.
That sure does increase your lifespan.
That was my other, if you're not available to be eaten 6 months of the year.
Yeah, it's the joke of why guys live less time because of doing stupid stuff.
Right, yeah. If you're not out where the predators are, then, there's or even if you're just not active, like while you're hibernating, you can't fall into a pit and you can't choke on some food that you shouldn't have eaten or whatever.
Get, bitten or stung by a venomous animal. You're not doing anything, so it reduces your risk. There's also a correlation between torpor-using animals and telomeres. Telomeres, we've talked about it on here. I think it came up in our genetics, but I can't remember.
Yeah, well, episode 147 was genetics.
And I know it's come up, but I can't remember where. Telomeres are the end caps to DNA strands. And these sections are, from what we can tell, non-coding. They don't hold any information. They don't do anything. But every time your cells replicate and your DNA is copied, the way the proteins attach to your DNA means that where it's attaching doesn't get copied. And you lose that itty-bitty bit of your DNA strand.
That the aglets on the end of your DNA strand slowly get smaller.
The telomere, these end caps of non-information, we think the most consensus that we have for what they are is a protection.
Yeah, a buffer.
You can wear these down and they will not damage important informative DNA. Now, this is not fully agreed upon for why we age and but telomeres seem to sync up with long-lived animals having longer telomeres, because eventually if your telomere runs out, DNA replication starts to damage your DNA. And that's one of the things that causes aging. Your cells aren't functioning as well because your programming's busted up a little bit. It's just not as efficient. It's losing data. It's not, half a functional gene got erased. So now it's only doing part of its job and you're not doing everything you need it to do. Hibernating and torpor using animals seem to have typically longer telomeres. And during that torpor time, it also might reduce the degradation.
Yeah, because that functioning, that replication is happening more slowly.
Exactly. So not only do they seem to have proportionally longer telomeres, they're probably wearing them down slower. So it seems like long life might be connected to torpor. Once again, we do not fully understand what aging is.
Yes, that's a different episode.
This is things that correlate, that go together very, very consistently. And if that's the case, it makes sense that there might be a connection. Now, that was a lot of really good things about torpor. There are risks.
Yeah, I would imagine. Well, because we were just saying that if you're not out and about, you're not getting eaten by predators. But I imagine the corollary to that is if you get found while you're in torpor, you're getting eaten.
Yep. If you're all slow-mo when the predator knocks on your burrow.
Yeah. Well, this is why if you go out herping, if you go out looking for like snakes and lizards and stuff, going in the early morning can be very beneficial because if you find them, they're easier to catch.
Yeah, they haven't warmed up, and so they're less reactive. They're slower to respond. Absolutely, that can be. So it can have kind of two sides. You might avoid your predators, but if you don't, you might be more vulnerable.
You're not escaping them.
Yes. It also can lead to situations like fires and stuff where if your response to hard situations is let's bunker down, and you bunker down in a log,
right,
then you actually might be putting yourself in more risk for
now you're in the
disasters. You have put yourself in the middle of this disaster. It can also increase the likelihood of things like freezing. That, if you don't migrate and get out of the winter, if this winter's worse than you were prepared for...
Yeah. Or if your burrow's not as secure...
or something happens to it, then now you are stuck in the cold, and you can only lower your body temperature so much before you just start freezing.
Yep.
And for most of you, that's not good. Sleep deprivation, if that is indeed what those arousal for, that absolutely is a danger. If they're not arousing enough, if they have lower fat so they don't have the energy to warm up as many times, they might have sleep loss, which can be super dangerous, both to their mental functioning, but just overall physical health.
Yep, episode 161 again.
Buildup of metabolic waste. They might get toxic levels of things in their system from sitting inactive. Depressed immune system can increase the risk of disease. White nose syndrome in bats happens to hibernating bats.
Yep.
And
they're less capable of fighting it off.
Absolutely. Like warm body temperature, which we talked about in the homeothermy episode, is one of our best defenses against disease.
Yes, absolutely.
Staying warm is bad for germs.
That's what fevers are.
Yes.
You're burning out the disease.
Turning down a thermostat means that they can grow more easily, and you might not be able to respond quickly enough to fight them off when you do get infected. So there is this major trade-off. There's tons of situations where it's beneficial, but you also are in risk for things. Yeah. Not all of them are black and white. There are animals that can rouse and be fairly active during torpor, so they could still avoid a predator, or they could still go get nutrients. So it's not, one situation or the other. Different ones might be in more risk of one of these than the other. But there's definitely a trade-off happening.
Yeah. There's also the not uncommon risk with hibernating or torpor-using animals that if something disturbs hibernation or torpor, it can be problematic. This comes up a lot. We talk about this with warming climates.
Yes.
Or if you have a warm snap. We'll talk about this with plants, right? A lot. Where we had an unusually warm snap in February, and all the plants in my garden started growing because it was warm, but then winter's about to come back, and now all those plants are going to die.
Yeah, and now that they've wasted that energy on that growth, they might not have enough when it actually gets warm.
And that can one of the reasons that white nose is dangerous for bats, in part, is because it wakes them up during hibernation. It disturbs their hibernation cycle. if some sort of trigger happens, it gets a little warmer or something, and an animal comes out of hibernation, and it's not the right time yet, now they've wasted a bunch of energy. They might not be able to effectively get back into that hibernating state.
Absolutely, because like we mentioned, with a lot of long-term hibernators, these are based off of very strict, specific environmental cues. So if you get miscued, you misread the situation and you wake up, you warm up early, you might not have the cues in the situation to go back into hibernation.
Yes.
So if you can't survive the winter warmed up and active now, however much there is left, you don't survive to the next spring. I also wanted to, and I know this first section is going long, but there's so much with this topic, briefly mention some other forms of dormancy that are real similar, but not technically hibernation.
Excellent.
Hibernation is a warm-blooded animal thing, pretty much. But there are other forms of dormancy that are pretty much doing the same thing, but not doing it the same way. Ectotherms, cold-blooded animals, reptiles, amphibians, most of your insects, they don't have the same control of their body temperature and metabolism in all the same ways that mammals and birds do. So they can't just adjust because they can't warm themselves up. So they can't just cool down and warm up on command like a hibernator can. They will go dormant with the cold weather, typically.
Right. It gets cold. Now you might not physically be able to function anymore.
Yes.
So you have to go into some form of torpor.
You'll still see a lot of similar behaviors. This is often called brumation.
Yes.
It's very similar. You'll still see a lot of them that fatten up before winters to store fat, and because they won't eat. Many of them can't digest during cold periods because the temperature is too low for their stomachs to handle food without it rotting.
Yep.
This is why gators stop eating, because meat will just go bad in their stomach.
Yep. Not the worst place you want it to happen.
They'll find burrows, they'll find underground areas where they can be better insulated. So they'll still do a lot of the same behavior, finding a hibernacula, which is what the burrow is called.
And that's brumation and hibernation are sometimes used, like snakes will do that. They'll especially in northern regions, they'll crawl into fissures, they'll hang out and wait for it to get warm enough again that their bodies will naturally warm up and they can become active. Those are often called hibernacula. They're often referred to as hibernating snakes. Technically, we can split hairs on what the actual terms are.
Evidently, one of the big distinguishing things that makes it a valid term is that brumation, you do have to drink.
Interesting.
You do have to rehydrate. So most brumating reptiles will have to wake up and get some water, get something to drink during their brumation. They can't recycle the urea the same way. And I think it has something to do with like the natures of the kinds of fats reptiles use versus mammals.
Yeah.
That their fats can't hydrate them the same way.
Interesting.
So there is that was the technical difference I saw noted of like, this is different. You'll see arousals, but it's specifically to drink. Yeah. There's also dormancy seen in things like fish, which are also typically changing their body temperature with the environment. And in a similar way, it's been kind of debated whether or not they have hibernation or have true dormancy. Most of them slow their metabolism when the weather chills because they have to. But there have been found a few that do change their behavior during that time, like polar and Arctic fish, that their metabolism dips, but then they also are notably inactive. And that a lot of the energy saving comes from the fact that they choose to stop being active.
Yeah, sort of a soft dormancy.
Yeah. There was one noted that evidently does have metabolic suppression independent of temperature. So there are some that seem like they might be able to suppress the metabolism. They won't be able to control their body temperature, but they can save energy through metabolism maybe.
Right. Well, and I know that this is a thing that snakes, for example, will do, that in between eating, the organs of the digestive system are just not functioning or active for the most part.
Yes.
And then when they get food, their organs turn on.
Yes.
And they can activate all of these processes that otherwise... So this is sort of like parts of the body are in selective dormancy.
Well, it's like when you have tabs open on a browser and it's like, we're going to stop loading this tab so it stops eating up your RAM.
Yes.
When you open it again, it'll load back up and your computer will slow down for a second. So there are multiple ways to kind of do dormancy that are very, very similar.
Yep.
But technically, in the techniques used, different. Another one that comes up very often is diapause and arthropods. Insects use diapause. It's a period of dormancy, often for winter and dry seasons. But this is genetically pre-programmed and timed. So it's a different, it's not in response to the environment the same way. It is programmed in very solidly in the genetics and is, once again, just a different technique for doing the same thing.
Right. Going into a period of inactivity.
And then briefly, there are some things that are dormancy, but definitely not hibernation. A lot of animals just freeze during winter.
Yep, like literally freeze.
Literally freeze. Wood frogs, a lot of insect larvae, painted turtle babies can just freeze, survive freezing, thaw out when things warm up, and then go about their business.
Yep.
So this is one of those where it's like, this is not dormancy.
No, that's freezing.
Your body's not doing this.
Yes.
But they do have adaptations to prepare to be frozen.
Yes.
So their body does have things that it does before freezing happens to prepare themselves. So it's got this weird, like, you do have adaptations to prepare for a period of inactivity.
Yep.
But the way that inactivity is going to happen is the environment freezes you.
Yes.
So this is a way to wait out the winter, and it's not migrating, but it is not torpor and hibernation.
No, it's extreme.
They use all sorts of different techniques. A lot of them use sugars, glycose, as an anti-freeze agent.
Yeah, that interrupts the ice crystal formation.
And it acts as also a support to keep things from getting crushed by ice formation in the tissues and water extraction. So the body will get flooded. The wood frog uses this. Insects use it. The turtles evidently have a different form that uses less sugar. So there's many of them have different anti-freeze responses, anti-freeze proteins and stuff. The Arctic ground squirrel does kind of an opposite thing where they remove stuff from their bloodstream that would allow ice to form. Ice has to form on something.
Yeah, it has to nucleate on a central point.
So it can be a speck of dust or like a protein, a loose molecule of protein. And that's enough for ice to start forming, but you need a starting point. So if you just like fully distill your water to where there's nothing in it, then it's harder for ice to form. This is how you can get like the cool things they show in videos where they have a super cooled bottle and they hit it and it freezes instantly.
Yeah.
Because it was below freezing temperature, but there was no way for the ice to start until it was jostled enough to add that activity and cause it to freeze. Ground squirrels do this. The Arctic ground squirrel removes nucleating agents from its blood so that ice just can't form. It super cools below freezing, but doesn't freeze.
Wow.
But if it gets like jostled,
I was going to say, if you smack a ground squirrel while
it would freeze solid and die.
Wow.
And if the temperature gets too low, it'll freeze anyway.
Yeah, then there's no...
They all still have a lower limit to where you are now too frozen. Your agents aren't going to fight this much ice.
Wow.
So you can just freeze. There's the whole alligators freezing in the surface of lakes. Mm-hmm. They don't freeze, but they just freeze into the surface.
Yeah, they stick their head out of the water so that they can breathe, and then the lake just freezes around them.
So, like, these are all forms of winter dormancy, quote unquote.
Yep.
Yeah, there's a lot of that. The cryptobiosis and tardigrades that we mentioned in the news.
Yep, where they just dehydrate themselves and go into a almost not an animal state.
Which is also a way to handle freezing. If you're worried about water freezing, just get that out of here.
Get all the water out.
It's not good for you.
Well, and this is interesting because, we've been talking largely about animals doing this dormancy thing. Dormancy is also something that is achieved arguably to much greater extent in other forms of life.
Yes.
We talked about this in episode 135 with Allie about seeds, that plants will do this thing where they do dormancy at certain parts of the life cycle.
Yep.
A seed might sit down in the soil and wait for months to years until the right circumstances come along, and then it will grow. Bacteria can form cysts that all right, things aren't good, become a cyst, which is kind of just an inactive form of this bacteria, and wait for, I don't have any data in front of me, but I have a vague recollection of reports of bacteria being reported to survive as cysts for decades to centuries.
Yep.
Possibly longer.
I found one thing saying that up to 80% of bacteria in samples in the wild is dormant.
Wow.
That they do this all the time.
Horrifying.
Yeah.
That's just if the right circumstance comes along, there's just 5 times as much bacteria.
Yeah. And they'll do it when things are tough, but evidently they'll also do it when populations are stable. When a bacteria culture reaches stable levels, a lot of them go dormant because then that's how you maintain the stability.
Yeah.
And so just turn off. So it can also be a reaction to not overpopulate and not compete.
Yeah.
So it's crazy.
It's just a thing bacteria do.
Yes.
Just as and we've mentioned this in the podcast before, viruses can do this.
Yep.
Which are, quote, living.
Exactly.
That a virus can do that lysogenic cycle where a virus just takes some of its DNA and puts it in your DNA and it waits there until something activates it later in your life. And it's just this dormant viral strain in there. So this is an extremely common feature of life. The ability to, in one way or another, say, things are not the way that I need them to be. Let's just wait for a day or a year or a decade until the circumstances are right.
And that seemingly almost ubiquitous presence around life has led to a lot of questions about how has it evolved and how universal is it and how many times did it evolve. So after the break, we'll talk about that and get into the evolution and what evidence we have from the past of hibernation and torpor. As we were discussing before the break, a huge portion and a wide diversity of life, but especially animal life, show some form of what I saw called programmed dormancy. That they have some form of brumation, diapause, hibernation, some form of shutting down, handling hard times. This brings up the question of how many of those are separate origins, their own evolution of this solution, or come from similar or the same source. This is further, the suspicion is furthered by the fact that these are so similar.
Yeah.
Not only are they ways to be dormant, but the patterns are similar. The steps are often very similar. The exact mechanics are often different, but there's a lot of parallels going on. So it seems almost suspicious that these can all be their own thing, which has led to people looking into it. There's a lot of interpretations for how this could go. The evolutionary history of hibernation is not clear.
Sure.
This is a behavior, and the parts of it that are physiological are soft tissue stuff, so we do not have a fossil record of hibernation. We have examples, not a record.
Yes.
So we don't truly know. Even things like hibernation and daily torpor are often considered to be distinct, not in that they are separate. Many view them as a gradient between.
Right, they're two ends of a spectrum.
Yes, but they are different.
Yep.
Which one evolved from which, though, we don't know. Mm-hmm. Were there parts that came from separate origins? Views on hibernation have changed over time. The original view was that torpor reflected a primitive thermoregulation.
Okay.
That it was the old way. And that homothermy and maintaining your temperature was the updated.
Right. This is obviously the better, improved way of being an organism, which just also so happens to be the way that we are as organisms.
Yes. Part of this was because a lot of more ancestral mammal groups, more basal groups, are the ones that often show torpor, or many of them show torpor, like a large portion of them do. So it seems like primitive mammals likely were doing this, but us advanced mammals aren't. This is no longer seen to be the case, but there is still debate on whether it's a recent evolutionary adaptation or a more ancestral adaptation. Not primitive, but whether it came on early or more recently. A popular and often held for at least quite a time view of it was that it likely evolved when the first mammalians that developed homeothermy would then have the ability to alternate. That
it's sort of an offshoot of being able to maintain a stable body temperature might be very closely related to the ability to vary your body temperature.
Exactly. Like, same way that reptiles can't hibernate the same way because they can't control their body temperature. You have to first be able to control your body temperature to alter it.
Yep.
And classically, it's often been assumed that it was probably evolved multiple times, convergently, in different groups of ancestral or maybe extinct lineages from those early homeothermic mammals. One piece of evidence that might give us a glimpse into what the early forms of hibernation and torpor look like is the Patagonian opossum. Opossums are the oldest of the marsupial groups, so they are some of the more basal members. There are members that display torpor, doing things like fattening up before times of inactivity, and in labs it was confirmed that they can indeed engage in torpor. And the pattern they expressed was, as they called it, intermediate, kind of in between daily torpor and hibernation. So it may be that the middle of that gradient evolved first, and then daily torpor and hibernation evolved from this intermediate form.
Yeah, interesting. So, which does make some level of intuitive sense. It's very easy to understand that being in torpor for months is an advanced, a more derived version of that.
Intense.
But also the ability to very quickly switch in and out of it on a hours-long basis would also, it makes some intuitive sense that might be something that took a little longer to develop.
Now, there are animals that can use both. There are animals alive today that can hibernate, and then outside of hibernation can use daily torpor at other times of the year. So they aren't exclusive, but it does seem like there might be more evidence that one did not begot the other. They both came from an ancestral form. As far as the order of operations for how it came to be, there might be some evidence in the development of different groups of mammals today. Many mammals that hibernate are altricial, meaning they're born helpless, like us, underdeveloped, they're not fully functional, they're not fully independent, and many of them are born without the ability to be homeothermic. They are poikilothermic. They are, much like a reptile, dependent on the temperature surrounding them, which often is the body of the parent that is taking care of them.
And it's one of the reasons why it can be beneficial to have that parent around, because it helps to regulate the body temperature of the young.
But then they will develop homeothermy later in life, usually around 1/3 or half adult size. It's fairly consistent that when they reach to 1/3 or half of their adult size, that's when they develop the ability to maintain their body temperature.
Interesting.
The order in which they develop that and then the ability to have torpor is different in different groups. So it might suggest a different evolutionary path. In birds and marsupials that show torpor and are altricial, they are poikilothermic at birth, develop the ability to regulate their temperature, and show torpor at the same time.
Okay.
When they get the ability to maintain their temperature, they can now go into torpor if need be. So basically, that supports the idea that poikilothermy evolved, then homeothermy and torpor simultaneously in that group. Placental mammals, they are also poikilothermic at birth. They then develop homeothermy, then later develop torpor.
Okay.
So it seems like there was a 3-step process potentially in the evolution of placentals, which does suggest potentially 2 evolutions of torpor in mammalia.
Yeah, in both of those cases, it does suggest that homeothermy is an important part of it.
Yes.
That they're coming about either one after the other or simultaneously, but you need that temperature regulation ability in order to be able to go into torpor.
So it supports that it probably came about in mammals after homeothermy was a thing,
Yeah.
But the way that it developed might have differed in at least these two lineages.
Yeah.
It's also notable to point out that though birds are similar to marsupials, they are not ancestral with marsupials.
Not even close.
So that suggests at least a third form of torpor. So that is some strong support for multiple convergent origins of torpor and hibernation.
It also suggests, again, that torpor and warm-bloodedness are related in this way. And the fact that birds can do it makes me wonder how many dinosaurs were able to go into torpor.
Absolutely. And we have some evidence, but we'll get to that in just a moment.
All right. I said it, and then the listeners can't see this. Will made a face, and I went, "Oh, we're going to come back to this later."
Yes, we are.
Oh, yeah, exciting.
I found it's interesting. There is evidence potentially against the multiple origins or for a single origin. And one of the big ones is just the fact that there's so many similarities.
Yeah.
A lot of researchers have pointed out that it seems almost unlikely that the same mutations for such similar forms happened completely separately in these groups. That just seems like it might go against Occam's razor. It might be less likely. It's also in the fact that we see certain traits that are not in torpor presenting animals, but have parts of the torpor requirements. Certain kinds of behavioral hibernation in reptiles. The one they've cited in this one was a green lizard. They didn't specify which species in the one, but that there are reptiles that show some form of it. Us humans and other non-hibernating mammals often still have some capacity for reducing body temperature. Even though we're not going into torpor, there is a mechanism for one of those steps. Now, this would suggest, if it is a single origin, that all of us non-hibernators lost it.
Right.
And so that is the flip side of this is if it didn't evolve multiple times, then it evolved once, and then all of us who are not hibernating lost the ability at some point. And that full homeothermy is a secondary trait.
Right.
Which is counter to what is typically considered the pattern or situation, but has been proposed by many researchers.
Yeah, well, and it does seem a little bit counterintuitive because hibernation and torpor are such an unusual, extreme-seeming thing to us.
Yep.
But as we've discussed, the ability to shut down for a while is extremely widespread and common among animal groups. And also, that makes a ton of sense because the Earth is not a stable place.
Yes.
Like, no matter where you live on the planet, resources and conditions are changing over time. So it isn't completely ridiculous to suggest that some ability to regulate how much activity and input and nutrients and resources you need to adjust to fluctuating conditions around you could just be something intrinsic to animals. And then different groups have done different things with it, have gone a little more extreme with it, or have done away with it. That's not a completely bizarre thing to imagine.
Absolutely. So there is not a clear stance or major consensus. It does seem like typically the answer you will come across most often is multiple origins. That does seem to be the most common one. But there are proponents for potentially a single origin, or at least maybe fewer. Maybe single in mammals.
Right.
So
well, and it could also very well be, there could be an intermediate option here where early mammals developed a number of the tools that are essential for torpor, and then different groups developed torpor using those tools at different times or at different orders or whatnot.
Yeah, so lots of ways this could go. It's evidently still very studied and debated what the situation is. While we're talking about the evolution of these things, I also found a paper talking about the potential pattern for evolution of diapause in insects, which is interesting. This is thought to likely have evolved for dealing with increased seasonality when arthropods came on land.
Okay.
That water environments are more stable, and we typically see less forms of torpor and hibernation in aquatic animals.
Yeah. Well, you don't have to worry about drying out.
Yep.
You're never going to have a drought in the ocean.
Yeah. Did the rain not come? Oh, no.
Yes.
It's still in the ocean. And that just aquatic environments, generally speaking, are more stable. They still have seasons.
Sure.
They still have forms of dormancy, but we don't see torpor and hibernation as often.
Right. Well, and a lot of the stuff that we talked about before, storms and fires and droughts and such, aren't going to be as big a deal in the ocean. You do still get fluctuating temperatures, fluctuating nutrient availability, predator activity, all that sort of stuff is there. Tides exist,
Absolutely.
and that is a back and forth thing. But it's not surprising that there's less of a need for... It's also... Arguably, it can be easier to move.
Yes.
We talked about this in episode 187 about migration. Migration and hibernation are kind of the two options for dealing with harsh conditions.
Yep.
You either find a way to stick around or you leave.
Yep.
And depending on your environment, some environments it's easier to just up and move. So there's maybe less of a need for hibernation.
Absolutely. So it's not that that's likely when it evolved in arthropods. And the paper I found suggested 3 stages of evolution that it might have taken, which is first, a development of neuroendocrine control over body functions. Neuroendocrine cells are similar to nerve cells, but also produce hormones like endocrine cells. And so getting control of their bodily functions through this hormonal nerve system.
Similar to our homeothermy,
Yes.
our metabolism maintaining our body temperature.
Second is pairing that with environmental changes, so that it responds to these colder temperatures, drier times, whatever it is. And then pairing it with seasonal indicators, so that you can go into diapause before the times get bad. And usually this is through some sort of biological timer.
Well, in episode 190, we talked about cicadas.
Yes.
And cicadas are an incredibly... And now, I don't know if what they're doing is technically diapause, but the idea that you have a life cycle and... this number of years goes by and then you emerge.
Yes, somehow your body's keeping track of time in a way. Seems to be very common in diapause. They noted that this is also similar steps to what likely led to migrational patterns in insects. But instead of metabolism shifting, it's movement shifting, but to the same kinds of indicators and potentially same kinds of timers.
Yes.
So it might be that insect migration and diapause have a very similar evolutionary pattern and even maybe source, but just different responses at the end for what you do at those cues.
Yeah. It also occurs to me that it's probably worth pointing out how many of the reasons that we discussed why hibernation and torpor are beneficial are tied to the activity patterns of other living organisms. Right. One of the reasons that it's beneficial to go into torpor during the winter is because the plants are dormant over winter.
Yes.
So I also wouldn't be surprised if there's a lot of coevolution when it comes to torpor and hibernation patterns, that plants are developing to go into dormancy during this time of the year so that the insects have to follow that pattern one way or another.
Yes.
And that this group develops torpor and then it affects another group's ability to function at that time. So they end up developing torpor to correspond to that or to be opposite of that.
Yeah. Did your prey migrate away? Well, then you probably should just take the dry season easy because the herds aren't here. So just shut down. Now, as we mentioned, because this is behavioral and because it's genetic or physiologic, like we can't see fat stores on fossil organisms, it is often very difficult to ID hibernating behavior or just that this species hibernated. There are plenty of groups, much like we do with many that have correspondents that are alive today, that we can look at and go, well, today all of you hibernate. Every species hibernates. So probably most of the fossil ones hibernated.
Like, yeah, here's a fossil species of bats that apparently lived in colonies in a northern region. Yeah, it's reasonable to say that probably they were hibernating.
I will not be surprised if we find that out, and I will be surprised if we find out you don't.
Yes.
But finding direct evidence is not always easy. But I did find some situations where we have what seem like evidence in the bones of hibernation. The oldest being Lystrosaurus.
Oh.
Lystrosaurus is a early Triassic relatives of mammalian ancestors.
Yeah, episode 47 for all those early synapsids.
These are great little animals. They got this little beak and these little tusks.
Lystrosaurus is fantastic.
Adorable and little, just like little bulldog fossil organisms. These fossils were Antarctic. Now, at the time, Antarctica was not cold and frozen like it is, but it was still polar. Mm-hmm. It was still closer, so it still would have experienced those extreme day-night cycles and lack of light during times of the year. So you still would have had dealt with very unusual times and probably harsh times where plant growth isn't as up and things would have still cooled down. So we've often looked at fossils from polar, regions, polar latitudes, likely being a situation where if hibernation's happening, could be here. They looked at the tusks, which are ever growing in Lystrosaurus, and found a pattern in the tusk that seems like it might sync up with hibernation. In the dentine of the tusk, the structural part of the tusk, they found evidence of prolonged stress, repetitive indicators of prolonged stress, which sync up with examples that we find in similar animals, and like similar tissues in hibernating animals. And when they compared tusks of non-polar populations, those did not have these stress patterns. So it does indeed seem like some form of winter reaction was happening with them. Mm-hmm. And if it is indeed hibernation, then it means that A, this is the oldest example we have in the fossil record.
Yep.
And it would demonstrate the behavioral diversity of Lystrosaurus.
Yeah.
Which may be why they're one of the only groups that survived the Permian-Triassic extinction, is that they might have been a very versatile and adaptable animal in situations like this.
Yeah. I wonder what the difference is in the signature in the teeth between stress because I was in torpor and stress because it was winter and I just didn't get enough food.
Yes, and I don't know.
I assume that there is something that they're noticing that's different.
And it may be that the prolonged aspect of it or the stress that it indicates. I did not see them specify.
Yeah, that there may be a specific signature in the tissue. Like, this is what happens when your metabolism drops and you go into a torpor state.
And it may just be, I think it's part of it is that it seems very similar to other examples. For instance, we have similar indicators in the teeth of fossil ground squirrels, which match up with modern ground squirrels that show a similar pattern of shift in metabolism, metabolic stress.
Yeah.
That is syncing up with their hibernation cycles.
So not necessarily just you weren't eating and sleeping enough, but your body went into a different functional state.
Yeah, so it's that seems to be. Now, I'm sure there might be other situations that could cause it. This is a very different group of life at a very long time ago and a very weird Antarctica, but that's our best evidence for our oldest understanding of hibernation right now.
Yeah.
There are also evidences for cave bears. Cave bears were around in the late Pleistocene in Europe, famous and characteristic features and a lot of cave deposits in Europe. Lots of cave bear sites have tons of bone remains and have been interpreted as likely being individuals who died during hibernation in those caves. Very similar habitats to places we see bears hibernate today. And there seems to be support due to isotopes in bone collagen from some of these specimens. When bears hibernate, we mentioned the fact that they have to live off stored fat and recycle their urea, and this changes the values of certain isotopes in their body and in tissues of their bone, including in certain tissues, including bone collagen. One of these is nitrogen isotope that gets elevated during times of hibernation. I also saw them note a certain isotope of carbon that shifts. I didn't see what it does during hibernation, but nitrogen was noted as increasing during hibernation. So finding a pattern of nitrogen in these cave deposits might indicate whether they were indeed hibernating or just visiting a cave.
Yeah.
And they found indeed that it does seem like they were hibernating and gave them idea of how long they were hibernating with the amount of increase in nitrogen. So they can get an idea of the lengths and patterns of hibernation in these bears. They were also able to get an idea of what the family structure and potentially developmental patterns are by looking at ontogenetic, the different phases of life of the different bears, and finding potential relationships between the female bears and young during hibernation that might give us an indication of how it relates to the patterns of today's bears. And with some of them, they were able to study the mitochondrial DNA to get an idea of how related were groups, and found that different sites seem to be very conservative in relation, that they are returning to the same cave through a familial lineage.
Yeah, that this family lineage uses this cave.
Yeah, at least on the female side.
Right.
Whether the males are following that, but at least the female side, it seems that they are returning to the caves that the female that gave birth to them used previously.
Very cool.
Yeah, so we can actually get a fairly decent view of what cave bears were doing hibernation-wise and how it compares to bears today. I also found some study looking at trace evidence of torpor in hibernation, specifically estivation burrows. Now, estivation we didn't mention in the first part, but one of the times that you can use torpor is during hot times, which for some means hibernation during the summer.
Right.
This is often called estivation.
Okay.
Estivation is, instead of hibernation, which is for winter, estivation is for summer. That's all it is.
Sure.
It's the other term for the other half of the year, basically. But it's for warm hibernation. Many animals that use estivation during hot times do it in underground burrows where you'll get into cooler soil temps.
Yes, you're protected from the hot temperatures outside.
And these burrows can preserve in the fossil record.
That's true.
Now, not many have been connected to estivation. You can find a burrow, that doesn't mean it was
right. There are lots of animals burrow for lots of reasons.
Absolutely. But there are evidently some. Now, I didn't find these specific studies and how they were connected to estivation, but this paper noted that 4 types have been connected to estivation burrows, and it was a Pleistocene earthworm chambers, Devonian and Cretaceous lungfish burrows, which, for anyone who doesn't know, lungfish will go into these mucus sacs underground and just wait out tough times, because if having lungs wasn't weird enough...
They are covering all their bases.
They're just, you can't kill me.
No matter what happens in this environment, I'm ready for it.
Tardigrade, I'm coming for your metal. Permian lysaurophid burrows, which are burrowing tetrapods that are kind of evidently snake-like, like long, slim-bodied.
Yeah, I think this is one of those early tetrapod groups that, early amphibian-like groups. And yeah, a bunch of those went serpentine.
Yep. Evidently some of these burrow, and these seem to sync up with estivation burrows. And then also Permian and Triassic dicynodont burrows, which is the same group that has Lystrosaurus.
Yep.
They've also found burrows that seem to match up with estivation burrows, which is another form of potential torpor and hibernation for this group.
Interesting.
So there does seem to be multiple lines of evidence that dicynodonts, Lystrosaurus and its cousins included, were a torpor-capable group.
Yeah.
Which might mean that's part of why they were able to survive so well. Now, as to your earlier comment, dinosaurs, it seems like there's mixed evidence.
Okay. That does not surprise me.
Yep. And we've talked about some of this before when we did polar environments.
Yes, in episode 114.
We do have evidence of polar dinosaurs. Not a ton, because those habitats haven't fossilized as well, and some of them are hard to get to nowadays. But we do have polar environments. We don't have a lot of knowledge about what their full life cycles were like, but there is some evidence of what their life cycle was doing there, which will give us potentially an indication of how they were handling winter. One of the biggest findings was a Cretaceous site from Alaska, Prince Creek Formation, where a bunch of young dinosaurs were found.
Yes.
Prenatal and juvenile dinosaurs, and many have interpreted too young to be the result of groups coming back from migration.
Yeah, we brought this up during the migration episode, 187. This was part of the evidence against, not that no dinosaurs were migrating, but that for a while the suggestion was, in order to survive it so far north, dinosaurs must have been migrating because they couldn't possibly have stayed the winter.
Absolutely.
But then when researchers found these are too little, these are too young to have made the trip back here. If they were being born in a warmer place, they could not have gotten back here whilst in the time that this would indicate.
Yes.
So this suggests that they were sticking around over the winter.
Yeah, that they were overwintering. And part of this is because 70% of the families of dinosaurs and birds known from this site show young. So the vast majority of groups known from this site seem to be overwintering. So it seems like that was more the case than migration was if there were any members migrating.
Yeah. In the migration episode, we also talked about fossil evidence for migration in dinosaurs.
Yes.
So go check that out after this if you want to hear that part.
Absolutely. Now, this is potential support for hibernation or some form of brumation or something to overwinter, especially with young.
And especially in Alaska, where, if I remember correctly, the Prince Creek Formation is, at that time, would have been even farther north than it is now, and reconstructions of the position of this area at that time puts it at like 85 degrees north latitude or something. So, these were dinosaurs that were hanging out with Santa.
Yeah, like...
way up north.
Not as cold as they. Still would have been very cold.
And also dark.
Dark. And as we've talked about in many other episodes with thermoregulation and giantism and everything, and dwarfism.
144.
Small bodies lose heat faster.
Yes.
That's why many small animals have to use torpor and stuff during cold times because they will freeze quicker than a big one.
Yep.
A moose can just trudge through the snow during winter.
Yes.
But a tiny mouse has to do something or else it will freeze. Young are going to face a similar problem. So it's suggested that very potentially that means a lot of them had to be doing something to survive the winter. But analysis of bone microstructure from other polar habitats from Victoria, Australia, and Antarctica in the Cretaceous, at least for Antarctica, I don't know if they all were, seemed to show that polar dinosaurs were growing at the same rate as non-polar dinosaurs. So it doesn't seem like they had periods of lowered metabolism and AKA lowered growth.
Yeah.
So
okay,
we have situations that really would make sense for hibernation, but it doesn't seem like we have any physical evidence for hibernation, and in fact evidence against it.
Yeah.
I don't know that any of these are from the Prince Creek Formation, but other similar latitude habitats. So...
all right, so jury's out.
Yeah, as we often say, I'd be surprised if there wasn't some form of hibernating dinosaur. We have reptiles and fish today that can just about hibernate.
Yes.
So, surely...
And birds do it.
Yes.
So, yeah, absolutely there must have been hibernating dinosaurs.
But we only know of one group of birds today that truly hibernate. So maybe they only used torpor for the most part. Maybe it was mostly daily torpor and not full hibernation. We're not sure. Speaking of dinosaurs and them dying, in Cretaceous extinction comes up in regards to the evolution of torpor and an evolution of mammals, because there have been many things that have linked that it seems like heterothermic animals tend to survive extinctions better than homeothermic mammals. And likely because they can adjust to a changing situation better than an overly stable animal.
This is interesting because this has come up basically anytime we talk about extinctions. We talk about how the species that are more likely to survive extinctions and the patterns that we see in the fossil record tend to favor organisms that are more flexible and more generalized in their habits. Species that can eat a variety of foods are going to be better off. Species that can live in a variety of different habitats are going to be better off because if resources are limited or if circumstances are unstable, being able to be flexible is an extremely valuable survival strategy. I don't know that we've ever specifically talked about that in terms of body temperature and metabolism.
Yeah.
But all this stuff we've been talking about, if you're a species that can adjust to deal with dry and wet conditions, very hot or very cold conditions, very food poor conditions, that all of this stuff we've been talking about, that flexibility would be extremely valuable in a scenario like the post-apocalypse of an extinction event.
And the patterns we see do seem to indicate that heterothermic groups have, on average, suffered lower extinction rates than non-heterothermic groups.
Interesting.
So they do seem to survive better, and it makes perfect sense that that ability to use torpor is a key tool during these harsh times. It has specifically been pointed out on the KPG extinction at the end of the Age of Dinosaurs, specifically due to potentially giving us the answer why mammals made it across as well as they did. because mammals were mostly smaller bodied than they are today. And smaller bodied mammals show high degrees of torpor. So it's likely that they could use torpor. And not only does that let you survive the extinction situation, but this specific one with tons of volcanoes going off and an asteroid hitting, causing potentially global forest fires, is one of the things that we mentioned earlier.
Yes. Well, and also that following that, there would have been periods of cooler temperatures, periods of warmer temperatures. This is not something we've talked about very much, and I haven't seen it discussed very much, but you have to imagine that weather patterns were just fully thrown off in the immediate aftermath of this.
And if torpor does indeed increase lifespan, it might mean that you can outlive the hard time. If you're an animal that only has 2 years to live, your generation might get wiped out during this post-extinction period just because you can't live long enough. But if you can live twice that long or 3 times as long as your competitors, you might be able to outwait the tough times.
Well, and it could also be that, immediately post-asteroid impact, you have your post-impact winter, there's less sunlight, temperatures are cooler. That might mean that plants are struggling and plants are only able to be active during the peak of the summer.
Yes.
Right? Whereas it used to be you could nom on plants from early spring all the way to the fall. It might be that in certain habitats, plants are now only active a couple months of the year if you are a species that's able to do what you had mentioned before with certain rodents and just be dormant for 11 months of the year.
Yep.
You can wait that out. You can match your cycle to what the plants are able to do.
And one of the main pieces of evidence that really spurred a lot of people to this idea were tenrecs. So tenrecs, small mammals, I think they're in the Afrotherium group.
I think so. And they live in Africa.
Yeah. They're super weird, prickly shrews.
Yeah, they're not rodents.
Nope.
They're a weird little mammal offshoot.
They got the pointy face of a shrew, but then they have quills and stuff. Super weird, super cool. They can click their quills. I love them. Certain tenrecs hibernate and show hibernation, but they don't show the periodic arousals. They don't have the warming periods during their hibernation that almost every other hibernator has. So it's just straight deep hibernation for a long period. I didn't see how long-term they typically can go, but this is potentially key because, as we mentioned, those times of arousal, those times of warming up and becoming active are the most costly. Up to 70 to 80% of the energy used during hibernation is just during the times that they have to warm up.
Yep.
If you can eliminate that 70 to 80%, that means that you can survive through very harsh periods with a huge energy saving. If early mammals, if Cretaceous mammals were able to hibernate the way tenrecs could, that would make them just masters of weathering super tough situations.
Yeah.
And they are in a similar size category. They're
Yeah, so it's not outside the realm of possibility that some of those Cretaceous mammals might have been able to do something like
this
that.
unusual example of hibernation was one of the main things that made people go, well, wait, if you can do that, you can survive that apocalyptic event. This is a game changer. So it seems like there's a lot of evidence that this might be why we see such success of heterotherms over extinction events, but also potentially why our lineage made it across one of the most recent, most devastating ones, and were able to diversify the way we did after. Now, about the next one, the way we're changing the world is also going to have interesting effects.
Yeah.
There's a lot of research looking into how will hibernators and heterotherms react to anthropogenic influences. Climate change being the biggest one, but also us changing environments, spreading diseases, spreading invasive species, all the changes we're making. And a lot seem to think that it will probably be, extremely varied in how different species react, but also different types of hibernation might be more and less affected. Deep hibernation probably won't fare as well. Deep hibernators are very stable patterned, looking for stable situation, and set. They react to set cues.
Well, they react to predictable cues.
Yes. So if those predictable cues are changed, If their timings change, like we were talking about earlier, with if a bat's forced out of hibernation early, that probably is going to kill that bat. And with us affecting the climate, affecting those cues, many of these animals are using barometric pressure, so changing weather patterns. Even if the temperature doesn't fluctuate where they are as much, if the weather pattern does, that could be enough to tell them, oh, this is spring weather.
Yes.
Nope, it's not.
And even if the hibernating animal isn't directly affected, if these environmental shifts are causing changes in the behavior of other animals in the environment or plants in the environment, that might be part of where the hibernators are getting their cues from.
Also, warmer years are going to mean shorter winters, which just means the timing might be off, that you're coming out too late or you're coming out too early, and the biological the pregnancies that happen during hibernation or developments that happen aren't happening at the right time anymore.
Yep.
They noted that especially for hibernators that are high altitude hibernators on tops of mountains where they hibernate there because it's cold, warming temperature is just going to push them closer to the peak. They won't have a place to move into, and it will let competitors move into their hibernation areas.
Yes.
So now they're going to be facing competition they didn't before. So your predators can come find you on the top of the mountain where you used to be safe.
Yes. Also, a lot of these changes that we're making to the environment are causing species to go extinct either completely or regionally, which could mean that even if a hibernator is completely unaffected by that, that hibernator might wake up and come out of hibernation and their food isn't there.
Yes. Well, it's like polar bears.
Some other thing has driven it away.
Like polar bears coming out of hibernation and then not being able to hunt on the ice sheets.
Yes.
Because the ice sheets aren't sticking around long enough.
Yes.
So they are hibernating just fine, but now the time they used to be able to take advantage of, we've changed. Daily torpor, though, probably will give a lot of advantages to animals in the face of our chaos.
Yeah. That's kind of what it's for.
Yeah, similar to surviving those extinctions, the changing, shifting environment, the changes in resources, the changes in temperature is kind of what daily torpor is ideal for. So it's very likely that we can predict that hibernators are going to suffer and might need more attention for while we're trying to engage in conservation efforts, while animals that can use daily torpor might be doing better, and hopefully might be some of the success stories in the coming future that we are creating.
Yeah. Interesting.
There are as always, so many other things. Even though we mentioned bears a number of times, there's a whole bunch of stuff about bear hibernation that's
weird.
That's weird.
Yep.
I found like a paper that was just all about bear hibernation. Huh. If we missed your favorite example of hibernating animal, let us know.
Let us know.
If there are other cool things about hibernation that you know of. There's lots of really extreme examples of specific things, or where they hibernate, how they hibernate, how they gather food.
Hop in the Discord and chat with each other. Send us requests to our topic request form if you want to hear more further topics. Before we wrap up on hibernation, I will mention one more example that we didn't mention in the fossil section, and we talked about this just a couple episodes ago. I think it is perfectly fitting to end our discussion about hibernation with a fossil species that is named after hibernation. In episode 197 in the news, we talked about a new species of fossil snake named Hibernophus.
Yes.
Because this was from somewhere in the western U.S., an ancient boa. Several fossil skeletons were found in the same space in what might represent an ancient hibernaculum.
Yes.
Where these snakes were overwintering together.
Absolutely.
Which is pretty cool.
So, we've got there's so much more to learn, about the history of it, but we got some cool examples. We are still trying to fully understand what the diversity and causes and functions. There's a ton of research on whether or not it is capable in us humans. There's no examples but people looking into it to try to understand, but also boy, that would make space travel easy.
Sure would be convenient.
So NASA's looking into, is there a way to get us to use torpor or even hibernate? Because if that's the case, that sure would make things a lot easier. So it is a very active field of study to try to understand this crazy phenomena that life uses. But for now, we will put it to rest. And we will move on to our last section, which is our patron question.
Yeah.
every episode, we like to answer a question from one of our patrons. If you sign up at certain levels, you can submit them to us and we'll answer them here. What's our question for today?
This episode's patron question comes from Ryan, who asks, on your show, that's this podcast, you often characterize the animal groups you're discussing as weird. That's true. We do say that a lot.
Yep.
Based on the discussions I've listened to so far, Ryan says, I have to agree. Are there any animals or groups of animals you would classify as not weird?
Yeah.
I love this question.
I really liked it for this episode because we were talking about how torpor is weird, hibernation's weird, but actually most groups of life do some form of it.
Yes.
So
it's not that weird?
It's not that weird, but it is so weird. And like my gut answer is no, I can't actually give you a group of life that I would consider not, because weird and not weird is like what's normal.
Right.
Like when you take a psychology or sociology course, they'll talk about the fact that norms, social norms, is just what's accepted.
Yeah, just what first comes to mind or what's most common.
In certain times in history, it was accepted to kill your neighbor if they offended you. Other times, not so much.
I think that I love this question because I think there is an answer in some respects. Like most of my favorite animals and the animals that I think are the weirdest are the ones that are highly specialized or highly derived. I think snakes are super weird because they're doing something that's not particularly common. I would say rodents.
Yes.
Like mice would strike me as not weird because they are kind of the default of what a mammal does in many respects. Salamanders, not very weird, default tetrapod. But absolutely mice do weird stuff and have weird things.
Then you zoom in and go, wait, you have ever-growing teeth.
Yeah, your incisors grow forever.
Iron coating on the front that lets you chew through basically whatever you want.
Yeah, a bunch of salamanders can just alter how many of their life stages they go through.
Yep, or have lungs or not.
Yep. So I think Ryan has sort of called us out on something that is you could see as an inconsistency in our way of portraying nature, where if we call everything weird, then
no one is.
Then no one is. But I think that is absolutely part of kind of the core premise of what fascinates us about life. Yeah, all life is weird.
Life is weird. A bunch of molecules and chemicals grouped together to then move around its environment under its own metabolism and motion, and then some of that eventually got to the point where it could recognize itself and the universe. Like, that part of the universe is looking at itself, and that's weird.
Yes. Well, one of the most common, widespread, influential forms of life on this planet are plants. They are, so as Allie has pointed out, they are the only organisms you can see from space.
Yep.
That's why the Earth is green.
That's weird.
And that's weird. And they are arguably, you could say, that is one of the most normal and expected forms of life on Earth. And they're so weird we have to bring in another person to the podcast to teach us how they work. So like we've said in the past that part of our sort of philosophy towards nature is that every species, every topic could be a documentary. It's why we do the podcast the way that we do.
Yes.
And kind of part of that is that, every animal is weird.
Yeah. Well, it's very much the way I made peace with stuff when I was a teenager and trying to figure out like what's okay and what's right and how should I be doing stuff. And I had a realization of everyone's weird. Like sports fans are weird. You follow a group of people who are super physically fit and use that physical fitness to throw around some form of inflatable object usually. They all have banners and heraldry that you wear on your chest while you watch them do this odd thing. Nerds are weird. You've memorized this fictional world and all the names and rules in it. And scientists are weird. And everyone is weird if you look at it the right way, but that's why it's all cool too. Like, yes. Absolutely. Yeah, I get why you like that. For me, it's not what I'm into, so it's weird. But for you, what I do is weird. I have a shelf full of toys and little plastic geometric shapes that I've put together into a different shape that I like better than the shape they were in before, and I've stacked them together on my shelf, and sometimes I'll change the shape and it'll make me very happy. What?
And I think that this is really... It's not something that I would ever have thought of to express this way, but since Ryan has asked this question this way, here on the podcast, we very often use weird as a synonym for fascinating.
Yes.
Like, that's why we geek out about, this is such a weird thing. And I think if there is a takeaway point, if there is a message to take away from how often we refer to living organisms as weird or processes as weird, it is that every living species, every part of the planet, there is something surprising and unexpected and fascinating to be found if you look there.
Absolutely. There's something to be discovered.
Yes.
Whether it's you're learning about it for the first time or we're seeing it as a global society for the first time.
Yes.
We can discover new things about basically everything. And that's awesome. And weird.
And so weird.
So weird.
So weird. Ryan, thank you so much for that question, you weirdo.
And with that, let's wrap up the episode. Check out the blog. We'll have lots of links and pictures. Like I said, there's so many cool things. There's tons of cool examples, so feel free to share and explore yourselves and let us know what your favorite aspect of being able to just turn it off for a little bit. We're still at Dragon Con for a couple days, so if you're here, come find us. Let us know what weird thing you've been doing. Or have you had to use any torpor to take breaks from the con?
Sure.
Because, man, if you could torpor during Dragon Con...
Oh, my goodness.
Oh,
fantastic.
I'm in between two panels. We're just going to... Keep an eye out for the next spotlight and get excited for Spooky
coming up.
And then episode 200.
Next episode.
Lots of cool stuff on the horizon.
Episode 200. The 200th episode. Huh.
Thank you to everyone who requested this episode. Thank you to our new patrons and all of our pre-existing patrons for your support. Extra special tippy-top thanks to our top-tier patrons, Sarah May, Daniel the Bug Lover, Robert Mart, Bugs All the Way Down, and Melissa Barksdale.
Thank you, everybody.
And we release episodes every fortnight, which if you could hibernate, you could just wake up.
You just wake up for the next episode.
A fortnight, that's nothing. 2 weeks?
Piece of cake.
That's barely a hibernation. You could make it there easy.
This has been a very cool, long episode discussion, and I've used all of my energy.
Yep.
So now is a great time to go. Our understanding, what we've heard from our listeners, is that we are a torpor aid.
Yes, absolutely.
For some.
Yes.
So if any of you are in torpor right now.
Yes.
Not the same as sleep. Go listen to this sleep episode.
Which is even weirder.
Yeah, it really is.
Sleep is so weird.
It's such a bizarre...
That might be my favorite episode I've ever led thus far. That one was so weird.
That's 161 for those of you who want to go check it out.
But this is a high contender. This one was very fun.
This was very cool.
Bye till then.
Thanks for listening to the Common Descent Podcast. You can follow us on Facebook, Twitter, YouTube, and check our WordPress blog for pictures and links after each episode. Huge thanks to our patrons whose support helps keep this podcast running and who get access to bonus goodies on Patreon. The song you're hearing is called On the Origin of Species by Protodome, which we found at ocremix.org. Thanks again for listening. We hope you'll join us next time.